In this video, we're going to be working on quadratics. We're going to figure out if something is linear, quadratic, or neither, and the attributes that go along with quadratic equations. First off, if I asked you, what is the linear parent function? What would you tell me? Don't tell me you don't know. It should be y equals x. If you went to graph that, your line, well, let's see, maybe I'll get a straight line here and do it. Your line would look something like this right here in the red. Okay, linear parent function. Now, the other thing is, if it was in a table, how do you know it's linear in a table? What do you first have to find? To see if something is linear in a table, you have to look and see if delta y divided by delta x is the same. That's because on every step up in this, on a line, it should be the exact same. Okay, well, what about if I had the quadratic parent function? First off, what is quadratic? Quadratic, we've got y equals x squared. And if you went to graph it, you would get this U-shaped looking thing that we call the parabola. Now, speaking of this, let's see. Now wait, let's go back here and talk to in a table. When you go to do a quadratic, to figure out if it's quadratic, in a linear one we did where delta y divided by delta x was the same. Well, in delta y, the first time around, you'd find that it was like -7, -5, maybe -3. And then if you went the next step and did another change in y, this would be +2, this would be +2. And if the delta y's are the same, then you've got a quadratic to the second, got an equation that's a quadratic where it goes to the second power. Now let's look at, whoop, I went forward a little bit too much. All right, maybe. There we go. Looking at this one, determine if it is linear, quadratic, or neither. So now what I would do first is I'm going to come over here and I'm going to do delta y, the change in y. This right here is plus, oh, not plus, we're going down. This would be -6. The next one, -6, -3, -6. Well, these aren't the same, but you have to go over here and check delta x, the change in x. +2, +2, +1, +2. So now I have the change in y over the change in x. Well, this is -6/2, which is -3. The only other one that's different is -3/1, which is -3. Whoops, that's a 2. Let's write the same thing. Here we go, -3. Well, since these are the same, that means that it is linear. Well, let's go ahead and remind ourselves and come up with the equation. I'm going to come over here and build my table a little bit bigger. Now, when I have all these ordered pairs and I'm trying to find my equation, I'll be honest, a lot of times I try and go and use just the positive one. So I have a 1 and a 1. Let's see here. If I put -3, so you have m, which is the slope, times your x. -3 times 1 is -3. What do you have to add or subtract to -3 to get to 1? You have to add 4. So your equation will be y equals -3x plus 4. All right, well, let's skip to this next one. Oh, there it was. Okay, let's figure out which one this is. So let's go delta y, the change in y, +8, +0, -3, -10. Delta x, +2, +2, +1, +2. Delta y divided by delta x, 8/2 is 4. 0/2 is 0. Okay, these are not the same, so it's not linear, But remember I said we needed to do delta y again to see if it's quadratic? This is -8, -3, -7. These are not the same, so it is neither. It is not linear. It is not quadratic. The next one, do delta y. Let's go through here, and I've got negative, not negative, I'm getting more positive. Let's try that again. Positive 26. Oh, big numbers. Positive 2. Positive 7. Whoa, positive 56. Delta x plus 2 plus 2 plus 1 plus 2. If I do delta y over delta x, 26 over 2 is 13. The next one is 2 over 2. That's 1. That's not linear. If I do the deltas again, this is -24 plus 5 plus 49. Okay, these are not the same, so it is neither. It is not linear and it is not quadratic. Okay, right here it says the graph of the quadratic parent function is shown below. First off, what's the equation for a quadratic parent function? Y equals x squared. Or you can write it let's try and write it. F of x equals x squared. Identify the vertex. The vertex is the point where the parabola changes directions. Here is the point right here. That point is 0, 0. Now, is it a minimum or a maximum? On this curve right here, is it the minimum point or the maximum? It is at the bottom, so it is a minimum. The next question asks us, what is the axis of symmetry? Remember, we call this the AOS, or the line of symmetry. This is where we can fold the parabola in half, and it's the same on both sides. So to draw my line here, the axis of symmetry is right here, which is the same as the y-axis. So yes, it's the y-axis, but what is the equation? The equation of this green line right here, which I drew kind of crooked, is x equals 0. It is x equals the x number of the vertex. The next thing it asks us for are symmetric points. This is where our y numbers are the same. So looking here, I've got this one and this one. They're on the same y's. I've got -1, 1 and 1, 1. See how these y numbers are the same? Another one. We've got 2, 4 and -2, 4. I've also got right here where they're the same on an exact point, 3, 9 and -3, 9. Here's the next one. What is the graph of this equation? Compare it to the parent function for number 7 if you need help. Well, it's this parabola, but let's go down here for a second and find the vertex. What is the vertex? It's the point where the parabola changes direction. Here's my vertex right here. It is 0, 3. Well, what happened between this parabola and the parent function? All we did was we moved it up. We shifted it up. Oh, I missed here. We shifted it up 3 units. So we shifted it up. So my equation is y equals x squared plus 3. Now, what is the axis of symmetry? Remember, that's where I can fold it in half and it's the same on both sides. Right here, I have, it is the y-axis, but is x equals the x number of the vertex, x equals 0. The next thing it says is, what is the symmetric point to 1, 4? So let's go over here, 1 and up 4. The symmetric points on the other side of that axis of symmetry, there it is, we have negative 1, 4. You have to make sure, because you want to make sure the y numbers are the same. The next one says negative 2, 7. What's the symmetric point? So I go negative 2 and up to 7. If I go across here, they've got to have the same y. It is 2, 7. They have to, remember, have the same y number right there. The next says, use the following word bank to identify the parts of the quadratic function both on the graph and the table as appropriate. So let's bring this down here. I wonder if I can move some of this. Yeah, I can move it down just a little bit. Or maybe I can move, nope. Let's see here. Okay. First off, this is the equation y equals x squared minus 4. Look, minus 4 right here. What is that minus 4? What is that compared into the parabola? Let's look at these words. It's going to be, well, I guess I should pause. Look at these words. And let's kind of see what's going on. This right here, we said the point where the parabola changes directions, that's the vertex. Here it is right here, 0, negative 4. And right here, so this is the vertex. Okay? So we found the vertex. Let's go up here and I'm going to get rid of that. Let's find the y-intercept. The y-intercept, here's the y-axis right here. If I go down, the vertex ends up in this case being the y-intercept as well. That is not always true, but in this case it is. Okay, so what's another thing they want us to find? The x-intercept. So let's go back down here. Here's my x. My x-axis, they cross at negative 2 and 2. Those are my x-intercepts. It's where they cross the x-axis. Okay. Next it says minimum point. Minimum. Well, down at the very bottom point down here, this is the minimum. All right, so I've done that. Now I'm going to go skip over here to axis of symmetry. That's where the point where we fold this in half to make the parabola the same on both sides. Right here, this line right here, I can fold it, and this is where it's the same on both sides. This is my axis of symmetry. Well, remember it's x equals whatever this number is of the vertex. So it's x equals 0 is my axis of symmetry. Symmetric points. Symmetric points are where your y numbers are the same. So let me go over here. Let me find the highlighter here. I've got this negative 3 in theory. So I've got negative 1, 3. Oh, I'm sorry, negative 1, negative 3. And 1, 3. Over 1 and down 3. Another one that I could have, negative 2, 0 and 2, 0. Right here. These are symmetric points. Another one that's on there, that's on the table, I've got negative 3, 5 and 3, 5. There are your symmetric points.